All right, we want to prove by the principle of mathematical induction that for all natural numbers n, the sum from 1 to n of this sequence 3i minus 2 is equal to n over 2 times 3 times n minus 1. All right, so first off, what I would recommend is just rewrite this series as such. So we have the first term of the series is, if we plug in 1, that would be 3 times 1 minus 2. So that's 1 plus, so if we plug in 2, 3 times 2 minus 2, that would be 4. Plus, 3 times 3 minus 2 is 7. Plus dot 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 plus, and then the last term of the series would be 3n minus 2 is equal to n over 2 times 3n minus 1. So this is essentially what we're trying to prove, because this here is just this, this expansion is this series right here. So let's go ahead and do proof by PMI, or the principle of mathematical induction. So the first thing we have to do is we have to establish if it works for the first couple terms, right? So base case, we're going to consider the statement concerning 1, right? So what that essentially means is we want to prove that 1 is equal to 1 over 2 times 3 times 1 minus 1, right? The first term is equal to this formula if we were to plug in 1, right? So we know 1 is equal to, so 3 times 1 is 3, minus 1 is 2, 2 times a half is 1. So we know the statement, if we were to plug in 1, is true, right? Now let's go ahead and consider S of 2. So if we were to do the statement for 2, right? So that's the sum of the first two terms. So 1 plus 4 has to equal this formula if we were to plug in 2, right? So we have 2 over 2 times 3 times 2 minus 1. So 1 plus 4 is 5. And 3 times 2 is 6, minus 1 is 5. 5 times 2 over 2 is 5. So we can see that this formula at least works for the first two terms, right? Now let's go ahead and start our induction step. So induction step, right? So we're going to suppose this formula is true for up to some kth term, right? So suppose S of k is true for some k contained in the natural numbers. So this implies that this is true, it basically implies that this statement is true for some k, right? For some natural number k. So this implies that the sum from 1 to k of 3i minus 2, right? So 3i minus 2 is equal to k over 2 times 3 times k minus 1. Or, instead of having it like this, we can expand this, right? So this basically implies that we are assuming that 1 plus 4 plus 7 plus dot 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 plus 3k minus 2, right? The sum of these terms is equal to k over 2 times 3k minus 1, right? So this is what we are assuming. Now, for the principle of mathematical induction, we assume that it works for up to some natural number k, and if we can prove that it works for the next term, which would be k plus 1, then it would work for any natural number we would plug in, right? So in order to prove that the statement works for k plus 1, we're going to add the next term, right? So this implies that 1 plus 4 plus 7 plus dot 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 plus 3k minus 2 plus 3 times k plus 1 minus 2 is equal to k over 2 times 3k minus 1, because that is this right here, right? That is the sum of these terms up to k, right? But then, look, we added this next term. So let me go ahead and move this. We added this next term plus 3 times k plus 1 minus 2, right? So what I eventually want is I want to get this here because I have this side done. If I can show that this side is equal to k plus 1 over 2 times 3 times k plus 1 minus 1, if I can show that this here is equal to that, then I've shown that the sum of the first k plus 1 terms of the series is equal to this formula, which is what I want to do. All right, so here, this right-hand side is equal to k times 3k minus 1 over 2 plus 3, so this would be k plus, so 3 times k is 3k, 3 times 1 is 3, minus 2 is 1, right? So what I have to do here is I have to get a common denominator. So essentially this is 3k squared minus k over 2 plus, and this will be 2 times 3k plus 1 over 2. And then this is equal to, so now we can combine these. So this will be 3k squared minus k, and then 2 times 3k is plus 6k plus 2 all over 2, right? Now, this is equal to 3k squared plus 5k plus 2 all over 2. Now, we can see that this is what I want to get to, right? So I want to prove that this sum of the first k plus 1 terms gets to here, right? So I have to do some work to get from where I am to where I want to get to, right? So let's see. Maybe I can go down here. So I know this is the same thing as k plus 1 times 3k plus 2 over 2, right? And let's see if this is actually the same as this. K times k is 3k squared. K times 2 is 2k. 1 times 3k is 3k. So 2k plus 3k is 5k, and 1 times 2 is 2. So, as you can see, this right here is the same thing as this, which this is the same thing as where we wanted to get to. Thus, we have that 1 plus 4 plus 7 plus dot 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 plus 3k minus 2 plus the next term, right? Remember, we added this next term of the sequence, 3 times k plus 1 minus 2 is equal to, we were able to get it to equal k plus 1 over 2 times, let me scoot this a little bit, times 3 times k plus 1 minus 1. So, aka, the sum from I equals 1, right, to k plus 1 of the sequence 3i minus 2 is equal to k plus 1 over 2 times 3 times k plus 1 minus 1. So we're able to show that it works for the next term, k plus 1, assuming that the formula worked for the kth term, right? So this implies that the statement concerning k plus 1 is true, right? So this is essentially what the principle of mathematical induction wants to do, right? What it does is we assume that this statement here works for some natural number k, and assuming that it works for some natural number k, if we can show that it works for the next term, which would be k plus 1, then the statement is true for any n that we choose, right? So therefore, by the principle of mathematical induction, for every n contained in the natural numbers, so for any natural number n, S of n is true. Hence, essentially what we wanted to show, right? That the sum from 1 to n of this series, or sequence, 3i minus 2, is equal to n over 2 times 3n minus 1. And that is the proof using the principle of mathematical induction.